In this video, we'll be making a unique picture frame with a retro twist. A floppy disk that not only looks great but also has a secret interactive feature. The floppy disk has a 3D structure with a nice soft touch feel, and when connected to your computer via USB-C, it acts like a save button. Pressing the disk triggers the save action on your PC, just like the save icon that resembles a floppy disk. This makes it a perfect gift for any computer nerd or a retro tech enthusiast. So, without further ado, let's get started. The first step is designing the floppy disk itself. I used Canva to create the design, starting from a reference picture I found on Pinterest. My goal was a minimalistic cartoonish look that still closely resembled a real floppy disk. To achieve this, I used simple rounded rectangles with black borders. A bright orange background was used to give the design a nice contrast. I tried to keep the dimensions of the disk as close to the real floppy disk as possible. The most common floppy disks are about 3.5 inches, mostly squarish designs. Looking nice. Next, I printed the design on A4 sized sticker paper. The floppy disk was divided into individual sections on one side, while the other side featured the complete design. I also added some text highlighting the peak usage era of floppy disks for a bit of retro context. Now we can carefully cut the different sections of the sticker paper. Using small scissors is a good idea, as this makes the tight rounded corners much easier to cut. To make a floppy disk, we'll be using a material called sunboard, also known as foam board. This remarkable material is sturdy and durable, yet easy to cut with a craft knife. It comes in various thicknesses. For this project, we'll need sunboard in 5mm, 3mm and 1mm thicknesses. Start by aligning each of the cutouts on the sunboard and tracing around them with a pencil. For the base section, which is the light grey square, I used a 5mm thick board. For the layers that go on top, I used 3mm and 1mm thick boards. After tracing out all the templates, use a ruler and a craft knife to carefully cut the sunboard pieces. For the thicker sheets, you may need a couple of passes to cut through completely. Pay extra attention around the rounded corners. They might need a bit more care to get just right. If you end up with any jagged edges, gently sand them with sandpaper to create a nice smooth finish, especially around the corners. Once everything is cut, you can align the pieces with the sticker paper cutouts to check the fit. If there are any inconsistencies, just sand them down to even things out. Now it's time to paint the sunboard edges. Since the original design has black borders, painting these edges black will create a nice seamless look. I used acrylic paint for this because it adheres well to the sunboard. Just make sure not to dilute the paint with water. Once you're done painting, let it dry completely. I did make a small mistake during the paint job, which I'll be showing in the next step. Once the paint is dry, we can get to the fun part. Carefully peel the stickers off their backing, making sure they don't stick to themselves. It's a nightmare to fix if they do. Now align the sticker with its matching sunboard cutout and press it into place. Repeat this process for each section of the floppy disk. Here you can see I made the mistake. I only painted the edges of the sunboard pieces. The sticker paper is so thin that the bit of uneven paint underneath shows through. To avoid this, I recommend painting the entire sunboard black instead of just the edges. But honestly, it's not too noticeable, so I think it'll work just fine. Now we can assemble all the pieces. I applied generous amounts of white adhesive to each sunboard section and used a scrap piece of sunboard to spread the glue evenly. After that, I carefully aligned the pieces and applied enough pressure to bond them together. Once everything is stuck and dry, a floppy disk should look something like this. Nice. Next, we'll repeat the same process to make the orange base for the floppy to sit on. I used 5mm thick sunboard for the base and I also made a cutout where the floppy will fit. The cutout is slightly larger than the floppy's dimensions so that it can move freely when pressed. Again, paint the edges of the cutout black for a nice finish. Now we'll start working on the mechanism that will let our floppy disk send the save command to the PC. But before we dive in, here's a quick word from our sponsor, Seed Fusion. Seed Fusion offers one-stop services catering to your needs, from design and customization to product and promotion. They offer PCB manufacturing, PCB assembly and hardware customization with global sourcing capabilities. Focus on your strengths, co-create and co-grow with Seed Fusion. Check out their offerings from the link in the description. Now, let's head back to our build. To trigger the save command, we'll be using a microcontroller. But not just any microcontroller will do. We need one that supports USB human interface device. This will allow it to be recognized as a keyboard by the PC. Plus, it has to be small enough to sit flush underneath the frame. A great choice for this is the Arduino Shao. This thing is incredibly tiny, barely bigger than my thumb. Despite its size, this is a powerful little device, packing most of the features of a full-sized Arduino Uno into this tiny form factor. Even compared to the ESP8266, which is already small for its capabilities, the Shao is remarkably compact, perfect for this build. First, we need to solder two wires to the Arduino. I connected a red wire to pin 2 and a black wire to GND. Before soldering the push button, it's a good time to upload the code. Start by connecting the Arduino to your PC with a USB-C cable. Next, go to the preferences in the Arduino IDE and add this link to include the Arduino repository. Then, open the boards manager and install the Seed SAMD board. I wrote a simple piece of code that simulates pressing the Ctrl and S keys on the keyboard when pin 2 detects the button press. Finally, we can upload the code to the board. Next, I soldered a small push button to the two wires from the Arduino. To keep it steady while soldering, I used a pair of needle nose pliers to hold the button in place. Just make sure to solder it in a way that the push button faces up when the Arduino is face down. Now let's make the back plate. I used another piece of 5mm thick sunboard for this. I cut a slot for the Arduino to fit into and a small hole for the wires connecting the push button to pass through to the front. As you can see, I have also painted the base plate black. I applied generous amounts of glue to firmly stick the back plate to the front. I then attached the Arduino in its slot with double-sided tape and fed the wires through the hole. Finally, I glued the push button to the front just below where the floppy disk will soon be placed. Now we can attach the floppy disk in place. First, I glued some sponge disks onto the base plate. I then glued the floppy disk to the sponges. This setup allows the floppy to move up and down smoothly when pressed. Since sunboard surfaces are typically quite smooth, it's a good idea to sand them lightly before gluing. As you can see, I have added some feet made of sunboard to raise it a bit and protect the microcontroller. Finally, I picked up an A5 sized photo frame from IKEA to give it a clean finish. Attach the frame securely and the build is complete. To test your save button, connect the Arduino to your PC using a USB-C cable. Now, pressing the floppy should save anything you have open on your computer. This works anywhere that uses the Ctrl S shortcut for saving. It works in Microsoft Word, Excel, and even web applications. With the IKEA frame, the floppy disk looks absolutely fantastic. It's a great addition to any desk setup. You can use the same method to create all kinds of shortcut buttons. A print button, anyone? I hope you enjoyed this project. If you like the kind of content in this video, consider subscribing as more are on the way. Thanks for watching and I'll see you in the next one.